Alright, in this video I'm gonna do it live. I'll show you, oh this is laggy, how to make a huge Christmas tree in no time. Let's say we want to do it here, so I'll show you how to do it. I haven't built it yet. We'll use a function and grasshopper dynamo. So you could do something like this, and then you can generate insanely massive structures in close to no time. It's a little bit laggy. I'm guessing OBS is hogging something, but yeah, you could also play a bit around with these functions, and I'll show you how it works. Say you wanted to make a tower like this. Boom. It's amazing. So it's Christmas. Let's try and see if we can make a Christmas tree for this terrain. Alright. So this is what it's all about, this definition here, but first we'll make the geometry in grasshopper. So this is some of the other ones that you just saw me creating, and I'll take you through it as we go. So first we want to start with a point for insertion, and we need at least one. Construct points, there you go. And then for the point we need, this is an initial reference point, and then we need a 0, 0 point, and then we need to create a line. So we'll say it can be maximum 150 meters tall. Put in the set, say 75 meters. Create a line, it will be the base of the tree. Like that, yeah. From there, create a cone. The base is 0.0, that's fine. Can we do it like this, and then detach that, and then do a radius of the tree? So it can be 75 meters in the radius. And we have a cone. So first I'll create a split of the inner line. So we'll do a divide function to this curve and maybe set a count of 40 points. Oh, this one. So now we have a division in here for branches, that's what I'm thinking. And then we'll divide the surface and cone surface, and we'll set a count of, I don't know, let's have a look how it looks with this. Lots of points, yeah. Then we'll do what's it called, random reduce. I want to make these points a little bit random, and reduction, we'll do a slider for that as well. I'm guessing to 100 or maybe 1,000. Let's have a look at that one. Create the data so we can preview it. Oh, that's a poor reduce. random. No. Let's have a look at the cheat sheet. I made this before. Ah, yeah. Need to flatten it. Yes, that looks a lot better. Alright, so we have a decent setup now. Then we need to create the branches in this. We'll use the A-left front here. We'll do a RT tree and closest points. So we'll do, this is the input geometry, it's a trunk. That's the tree, and we want to search for these points. So now we have some indexes. We'll get the item here, and then we'll take this list and this index. Let's see what it gives us. Swapping around search points to search from. What is wrong? 318. Take a line that will be the start point and the end point. Points into the tree, take the list, get the index. Yeah. What am I doing wrong? Divided surface into the tree, search for it, search for those points. You want this index to be based on that list. Yeah, that makes sense. And then the end point is there and the start point is there. Looks decent. So now we have some sort of random tree, so we want to see the branches only for now, so we'll just hide all of this. This one we'll need later. Hide. Alright. So now we have some sort of a tree here, we can adjust the branches, numbers and stuff like this. So we'll do something like this and then something like this. Alright, so I want to make this a little bit natural, so I think we should move these points. I'm thinking we will adjust a little bit in the x coordinates. So we'll say deconstruct points. We'll take this point and then we'll reconstruct it. So the same coordinates for x and z, and then we'll do a slider for offsetting branch heights. graft this one. Let's see how it looks. Of course. Need to add it like this. Boom. So 45 is obviously, this is way too high, so we'll just adjust these ones. We can go to 40 maybe, 30, 40. And minimum is -40. So we want to get something that looks like this. And then we'll move there. So now we have these lines. And then let's just take the initial one. That was this one, I believe. This one. Trunk. And then we'll do a move. So we have it all, and we'll move the trunk. The motion is unit set. And then we will put it like this and like this. And you know, maybe you would want to take this line, extend it a little bit, we'll do a slider from 0 to 10. Nine. That looks more like it. Alright, so here's our basic geometry. That's it. So what we'll do now is we'll take this, just remove it from this so we only have these. It's beautiful. And so to get this into Minecraft, we need to divide it into pieces. So first I'll just merge this because it doesn't matter. So we'll merge this line and this line, and then it's a flat list. And then we'll take it and we'll say division, divide. So with curves, what you want to do is divide them by length. So you want to imagine that each curve, I'll save this file before, sometimes this is heavy on the file. So I'll try and start with, set a number and say 10. Okay, that was fast. So we'll make it slower, we'll put in 1. Boom. So now we have tons of points here. And you know, I'd actually like to say 0.5. So these basically are coordinates for Minecraft. So I create a set. So right now we have what, 7,000 points? That's almost nothing. That's a tiny tree. And then you'll see the set contains also 70. Okay, so there's no double values, which is alright. You could round it up if you want, but the set removes double values. Alright, so to get this into Minecraft, first of all, let's make it bigger. So I think it should be at least like this and at least like this. That's more of a tree. And should we play around with the random stuff here? I think we're pretty good. Alright, so now we are on 14,000 blocks. Yeah, that's alright. 14,000 points at least. Alright, so we'll get this into Minecraft. So the way we do it is we go to our Minecraft folder, data pack. You can find this on GitHub. I go into my data, I go into this one and my functions. So here I have some functions, and I'll take a blank function here, or copy paste it, insert it, and then we'll call it Christmas underscore tree. And then I'll go into Minecraft, and this is my output. I'll take this panel and I'll say stream destination. Copy the path. So control copy. Come on. Really? Okay, we'll do it manually. We'll find the file. So this is your Minecraft user app data. It was saved for the world. So it's an app data roaming. Just call Minecraft then. Dot Minecraft. No. Roaming. Dot Minecraft. Here, saves. This is the world. We'll go into data packs, add it as a function in here, and I want to store it into the Christmas tree function, and I'll keep the extension. So this is fine. I'll press save. Yeah, replace it. Alright, then I'll activate this group. And what I want to do is to keep this simple. I think we'll just have a quick look in Minecraft, and we'll see what blocks we can use. Let's say acacia log. So we'll put in what block we want it to be here. Acacia underscore log. So this basically creates the command for all of these coordinates. So what this gives us is a huge file. Add a space in front. So now you have a file here containing 13,200 lines. If you go into Minecraft and the save folder, the functions and the data pack, then you will see now, if we open the Christmas tree, you'll see we have a huge file here. Cool. Let's test it. So we'll go into Minecraft, reload, takes the data pack in again, and then we'll say function, and there it is. And for scale, this is massive. Oh man, I love this. I've been playing around with this a lot. It's quite fun. So basically this way you can get, yeah, it's not a beautiful Christmas tree, but who cares? You can get tons of stuff into Minecraft really fast. So, and let's say you wanted to go above 65,000 blocks. This is so big. Then you split the script into two. So for this one, it's a roof structure. You could go into some blocks here. So this block is the reference block. So if I stand on this point, that's the relative coordinate. I do function, and then I take the walls, boom, then you have the walls of the building. So that way you can split your builds into multiple functions, so you get a ton of stuff. Look at the scale of this stuff, man. It just destroys the landscape. It's amazing. And you can make it even bigger. I mean, no limit. Cool. This is on GitHub, this repository, both for the data pack and this one. So feel free to play around, maybe with your kids, I don't know.